Hello, my dear students. Here I am back again with another discussion about metals and nonmetals. In the previous part, we were discussing about reaction of metal with water under different temperature conditions, right? Under that, we had discussed how metals react with cold water. There, we have understood that sodium react vigorously with cold water and it produce hydrogen gas, and it is highly exothermic that the hydrogen gas produced will catch up the fire. So we had discussed about reaction with cold water, and we also understood that magnesium, zinc, lead, iron, aluminium and copper do not react with cold water. Let us move further to understand how metals reacts with hot water. So reaction of metal with hot water. In order to understand this, here we have kept a beaker filled with water on a tripod stand below which a burner is kept. Okay. If I'll turn on the knob of the burner, then heat will be supplied and water gets heated up. That water has to be poured to each of the test tubes for our observation. Let me turn on the knob. You can see fire is being produced. So water is getting hot. It's hot, heated. Okay. I'm taking the beaker. So this beaker is filling up test tube A, B, C, D, E, and F, to which we are going to add various samples of metal given below, that is magnesium, zinc, lead, iron, aluminium and copper. Dear children, you might have observed here they have not given sodium because sodium has already reacted vigorously with cold water. If we make it react with hot water, it is risky. Already it has produced fire with cold water as it is highly exothermic reaction. So we are not supposed to test sodium and potassium with hot water. So now we have spatula here. This is spatula. With the help of spatula, I'm taking pinch of magnesium, which is white silvery in color. This magnesium I am pouring to test tube A. You should observe the reaction carefully what's happening. You can see here magnesium is producing some bubbles and it's floating, sinking. Its volume is reducing, right? It's actually floating, not completely sinking, sank below. So this is how magnesium reacted with hot water. It was floating, okay, and bubbles were produced, okay. Now let us take zinc. I'm adding it to test tube B with hot water. It's added to test tube B, no reaction. Let me take lead. Lead is gray color metal. I'm adding it to test tube C. No reaction again. I'm taking iron, silvery gray. I'll add that to test tube D. No reaction. I'm taking spatula and filling it with aluminium, silvery white metal, adding it to test tube E with hot water. Okay. No reaction again. Same spatula with copper, which is red orange color, and putting the solute sample, copper sample to test tube F. No reaction again. So here is a conclusion. Magnesium does not react with cold water, but it reacts with hot water and it starts producing magnesium hydroxide and hydrogen gas. Okay. It also starts floating because hydrogen gas produced gets stuck to its surface, which makes it float. And the equation goes like this. Mg plus 2H2O produce MgOH twice plus H2. Shall we move again? Next. Okay. Here is a setup to see how metals reacts with steam. Okay, in ninth standard, you have already studied, children, that due to latent heat of fusion, steam, fusion and vaporization. Actually, in this condition, it is latent heat of vaporization. Due to latent heat of vaporization, steam will have more energy than the hot water. Okay, so we are going to test how metals react with steam. In order to study how metals reacts with steam, we need this particular setup where we have boiling tube and glass wool, okay, which should be soaked in water, and a cork to close this boiling tube, and a delivery tube through which the gas will be passed to the setup, to this setup, and we have burner to produce heat that will make the glass wool get heated up, and water in the glass wool get converted to steam, and metal sample will be kept inside the boiling tube. Here is a stand to hold the boiling tube, and here we have water in a bathtub. It's called as bathtub, glass bath, it's black bathtub, and inverted test tube is that with water. Okay, when gas really get released through the delivery tube, it enters this inverted test tube. Let us make the setup first. This is boiling tube. I'm taking boiling tube to the, yeah, let's get to the stand. Glass wool is kept inside the boiling tube. Then one cork, it's cork with one hole, one board cork, okay, that's been kept to the boiling tube, and here is a delivery tube get attached to the inverted test tube. Next, if we click, we'll get samples of metals. Here metal samples like zinc, iron, aluminium, lead and copper has been kept. They have not kept sodium because I have discussed already in the previous slide, and even they have not kept even magnesium because magnesium has reacted with hot water already. So if we keep the sample inside the glass boiling tube, and if we put on the knob, then if it reacts, then we'll see bubbles coming out in this water. Okay, inverted test tube. Yeah, here zinc is being kept inside. I'm turning on the knob. Heat is getting produced. Yeah, zinc has reacted and bubbles are coming. Can you observe? Bubbles are coming. Let us see what are those bubbles shortly. Iron is kept. Knob is on. No reaction in case of, sorry, iron has also reacted with steam to produce the bubbles. Then I'm keeping aluminium. Okay, knob is turned on. Aluminium is also reacting with steam to produce bubbles. Then comes lead. Knob is on. Observe carefully. Lead is not showing any reaction. Then comes copper, kept inside the boiling tube. Copper is also not reacting. So with the steam, there will be reaction of zinc, iron and aluminium. Aluminium, iron has reacted with steam to produce respective oxide and hydrogen gas. The bubbles are nothing but hydrogen gas. Children, can you think how can we prove that it is hydrogen gas? Is there any test to know the release of hydrogen gas? Give food to your thoughts and try to answer by yourself. Okay, and the reaction goes like this. Al plus H2O produce Al2O3 aluminium oxide plus hydrogen gas H2. Fe plus H2O produce Fe3O4 iron oxide and H2, that is hydrogen gas. So whereas metals like lead, copper do not react with cold water, hot water or steam. Not just lead and copper, lead, copper, gold, silver, platinum, these are few metals which do not react with any form of water. So this is about how metals reacts with water. Let us understand the same with another slides. Okay. Here is the slide which we, this is the setup to see how metals reacts with steam, and this is also important for your examination viewpoint. This diagram may be asked for 3 marks. Reaction with water. Metals react with water to produce metal oxide and hydrogen gas. Metal oxides are soluble in water and dissolve in it to form metal hydroxide. Okay. But all metals do not react with water. As we have discussed, copper, lead, gold, silver, platinum do not react with any form of water. Metal plus water produce metal oxide and hydrogen gas. Metal oxide plus water again produce metal hydroxide. Highly reactive metals like sodium and potassium, as soon as it comes in contact with water, it produces metal hydroxide and hydrogen gas because the reaction is so vigorous. Whereas in less reactive metal, like we have seen in case of aluminium and iron, it produces aluminium oxide and iron oxide respectively, and hydrogen gas, which on further dissolving may produce respective hydroxides. Metals like potassium and sodium react violently with cold water. The reaction is so violent that it can catch fire, and it is exothermic that hydrogen evolved immediately catches fire. That's why sodium and potassium are stored under kerosene. It reacts violently with air also. It also reacts violently with water. For that reason, it is stored under kerosene to avoid its direct contact with water and air. Yeah. Here is a reaction which we have already seen for sodium, we have seen, not for potassium actually. Here is a reaction that is 2K plus H2O produce KOH and H2. As I said just before, in case of potassium, it produces potassium, and sodium, it produces potassium hydroxide directly. And sodium, you can see sodium hydroxide plus hydrogen gas plus heat energy because it's exothermic in nature. The reaction of calcium with water is less violent. This sample actually was not given in that virtual lab by Amrita Vishwa Vidyapita, Amrita O Labs, but calcium do react with cold water, and when it is put to cold water, it starts floating. The reaction of calcium with water is less violent, not as violent as potassium and sodium, but less violent, but it also starts floating. Like magnesium, we have seen in case of hot water. What would be the reason? The reason is due to the release of hydrogen gas, which got stuck to its surface. But it will also produce heat. The heat produces not sufficient to catch fire for the hydrogen gas to get that has been released. So the equation goes like this, that Ca plus H2O produce CaOH twice plus H2. CaOH twice is calcium hydroxide. Let's move further. Calcium starts floating because of bubbles of hydrogen gas stuck to its surface. This is very important, children. They'll ask 1 mark question regarding this. Why do calcium start floating when added to cold water? 1 mark question may be asked from it. So this is important. Because of release of hydrogen gas which got stuck to its surface, calcium starts floating when put to water, cold water. Now moving further, Magnesium does not react with cold water, but it reacts with hot water to form magnesium hydroxide and hydrogen. We have seen this equation in the Amrita O lab virtual lab animations, simulations. It also starts floating due to the bubbles of hydrogen gas sticking to its surface. Metals like aluminium, iron, and zinc do not react either with cold or hot water, but it reacts with steam to form metal oxide and hydrogen. Here I had given reaction of aluminium in the Amrita O labs. There was a reaction of aluminium and iron given, equation was given, Al plus H2O giving Al2O3 plus H2, right? Whereas zinc was not given. Can you write on your own for zinc? Zn, zinc plus water in it, in which form? Actually it is in steam form, that is in gas form. Okay, water, what would be the product when zinc reacts with H2O? What would be the product? That you should be able to write on your own, because it produces zinc oxide, respective oxide, and hydrogen gas. You should be able to write it. Okay, then aluminium plus H2O Al2O3 plus H2, Fe plus H2O Fe3O4 plus H2. Metals such as lead, copper, silver, and gold do not react with water at all. This can also be asked for 1 mark question. Okay, which are the metals? Name any two metals that do not react with any form of water. Any two metals, you can name it, no problem. Let us move further to understand about, yeah, here is a question about what you have understood till now. A time to think about what you have learned. Why does calcium start floating when it reacts with water? Write balanced chemical equation of the reaction. You should be able to answer it on your own. Okay. Name two metals which do not react with water. I have been stressing these questions while discussing previous slides. Please go back and learn the concept and try to answer it by your own. Reaction of metals with acids. Let us understand how metals reacts with acid. Actually, in the chapter Acids and Bases, you have understood the other way around, that how acids reacts with metal. The products remain same, but here we are going to discuss which are the metals which reacts with which type of acids, and which are the metals which do not react with acids, or which are the acids that do not react with metals. We are going to discuss about that. Coming to reaction of metals with dilute acid, it produces salt and hydrogen gas. Hydrogen gas, how should it be tested? You should remember that. We have discussed about this in your previous lessons. Write equations for the reaction of magnesium, aluminium, zinc, and iron with dilute hydrochloric acid. I'll write for 1 or 2, you write for the rest. Okay, magnesium with HCl, Mg with HCl. Okay, what should be the product? It should be a salt and hydrogen gas, and hydrogen gas, you know that it is H2. So salt should be from Mg and Cl part of HCl, that is MgCl2 plus H2, hydrogen gas. This is for magnesium. Let me write for zinc also, and you write for aluminium and iron. Zinc Zn plus HCl, it produces ZnCl2 plus H2. Okay, so this is for two metals that I have written. You can write for rest. Now moving further, hydrogen gas is not evolved when metals reacts with nitric acid. It is because HNO3 is strong oxidizing agent. This is very important again from viewpoint of your exam also. It's very important. So this HNO3 is a strong oxidizing agent. As it is strong oxidizing agent, HNO3 oxidizes H2 produced H2 ಜೊತೆ oxygen mix ಆದರೆ ಏನು produce ಆಗುತ್ತೆ water H2O and HNO3 ಏನಾಗುತ್ತೆ that get reduced to oxides of nitrogen. N2O nitrous oxide, NO nitrogen oxide, NO2 nitrogen dioxide. Okay, so like this oxides of nitrogen get produced, but hydrogen gas is not released when metals reacts with HNO3. The reason is it is strong oxidizing agent. Whereas again there is exception. Science is such a subject, it always accept the exceptions with open arm. So, in case of magnesium and manganese, it reacts with very dilute HNO3. It can react with dilute HNO3 to produce hydrogen gas, whereas other metals do not react with HNO3. Okay, shall we move further? This is about how metals react with acid. It produces metal salt and hydrogen gas. Question time for you. Complete the following equation with balancing. Okay, Al plus HCl. Al means aluminium plus HCl and Mg plus HNO3. Please try to answer by your own. Al plus HCl, Mg plus HNO3. Let us move further. Reaction of metal with other metal salt. How metals reacts with other metal salt, that we need to understand. This you have studied in chapter 1 as displacement reaction. Okay, as displacement reaction you have already discussed about this. Highly reactive metal displaces less reactive metal from its salt solution. It is called as single displacement reaction. You already have idea about it, so I'll not explain much. Highly reactive metal, for example, metal A is there and another metal salt is there. If metal salt of B of metal B is less reactive than metal A, then metal A and goes and takes the place of metal B from the metal salt. Okay, this is single displacement reaction. Metal A plus salt solution of B produce salt solution of A plus metal B. We can see a video related to displacement reaction again from Amrita O Labs. We should be very much thankful to Amrita Vishwa Vidyapita for providing resources regarding science virtual labs. Let us watch the video. So here we have the website. Let us watch the video. Single displacement reaction.
Single displacement reaction. We will require copper sulfate, iron nails, distilled water, a beaker, measuring jar, test tubes, 2 clamp stands, a piece of thread and a glass rod. Take sufficient quantity of distilled water in a measuring jar and pour it into a clean beaker. To this, add a required quantity of copper sulfate. Stir the contents in the beaker using a glass rod until the copper sulfate crystals in the beaker dissolves completely. Pour sufficient quantity of copper sulfate into a test tube. Clamp the test tube to a stand. Then pour sufficient quantity of copper sulfate into another test tube. Clamp this test tube to another stand. Take 2 iron nails. Clean these by rubbing them with sandpaper so the color appears grayish. Tie one nail with a thread. Immerse this into one of the test tubes containing copper sulfate solution. Keep the two test tubes undisturbed for about 15 minutes. After 15 minutes, the color of the copper sulfate solution containing the iron nail turns light greenish color, whereas the color of the solution in the other test tube does not change. The greenish color of the solution is due to the presence of Fe2+ ions. Remove the iron nail from the solution. Compare it with the other nail. There is a brown coating of copper on the nail that was dipped in the copper sulfate solution. The other nail retains its grayish color. In this reaction, the ferrous ions displace copper ions from the copper sulfate solution. So the reaction is a single displacement reaction.
Yes, dear children, you have seen there clearly that how iron reacts with copper sulfate. The color of copper sulfate was blue initially, which when iron nail was put, it has turned to green, indicating the production of FeSO4, that is iron sulfate, which happened because iron was more reactive than copper. Based on this reaction of displacement reaction, we can understand reactivity series of metals. So let us try to understand reactivity series or metal activity series by conducting various displacement reaction. Like here we have made copper sulfate to react with iron. And we have observed that iron is more reactive than copper. Similarly, with the copper sulfate, I will take zinc. If the reaction occur, that is color change occur, then zinc is more reactive than copper also. Then I'll take zinc sulfate, make it react with iron. Okay, by doing this set of displacement reaction, scientists have given us series of metals in the decreasing order of their reactivity, and that's called as reactivity series or metal activity series. Let us see that. The reactivity series is the list of metal arranged in the order of their decreasing activities. This is important. You need to remember the reactivity series, not because they'll ask you to write the reactivity series, but because it is very useful in application level questions or higher order questions that will be asked in the examination. I'm going to solve you for few questions from previous year papers also that will help you to understand how we can apply reactivity series while answering the questions. This is the reactivity series. You can see here most reactive metals are kept at the top and less reactive metals are kept at the bottom. Least reactive are kept at the bottom. So these are least reactive. K is for potassium, Na is sodium, calcium Ca, Mg magnesium, Al aluminium, Sudden zinc, Fe iron, Pb lead, H hydrogen. You may be thinking why hydrogen is kept here. Okay, hydrogen is not actually a complete metal, but it is kept in the reactivity series to understand from which metals hydrogen get released when it reacts with acid. Okay, and Cu copper, Hg mercury, Ag silver, Au gold. How can we remember this, ma'am? This is very difficult. How can we remember these many metals? I'll give you a trick to remember these metals easily, which I have learned from one of my colleagues. Okay, I'm going to share the trick with you so that you can remember it easily. Reactivity series. Let us go for the trick. Mnemonics, it's called as mnemonics for reactivity series. PSC magnetl hardly could make solid gold perfectly. It's just like a sentence. If you remember this sentence, you can remember the metals, because remembering each metals by its name is difficult. But you can by heart this sentence, these mnemonics, which help you to remember all the metals given in the reactivity series. Let us see which are the metals in this PSC magnetl hardly could make solid gold perfectly. P stands for, can you guess? P stands for potassium. Okay, potassium. First one, PSC, P for potassium. Then comes S for sodium. Yes. Then C for, you have guessed it correct, calcium. Then comes M. M for magnesium. Okay. Then Mac. A is for PSC is done. M is done. A is for aluminium. Aluminium. Then Mac Ma is done. C calcium is already done. This C is not actually for metal, it is for carbon. This C is for carbon actually. Okay, we'll discuss about that also. Why carbon is kept? Carbon. C for carbon. That is very important to know which is more reactive than carbon and less reactive than carbon to use as reducing agent during the extraction of metals. We'll discuss that in later slides. Okay, carbon C and Z is for zinc. Okay, then I is for iron. N I have given in capital, I have given in small, okay, because these two employs one. These two represent one Ni, one element. That's why I have given Ni. This is actually not given in your textbook, but you can remember. Ni is nickel. Ni symbol indicate nickel. Then Tl. T is Tl, tin. Okay, L is lead. Tin is also not given in your textbook, but it's okay, you can remember. L is for lead and H is for hydrogen. H is for hydrogen. Then we have, let us see, hydrogen. C is for copper. Then M is for mercury. Mercury. Spelling has become wrong. Okay, fine. Yes is for silver. Gold is for gold. And perfectly stands for platinum. So by this mnemonic, you can remember 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 elements at a stretch. By just a sentence, PSC magnetl hardly could make solid gold perfect. Okay, so remember this. This will be very useful mnemonic to remember your metal reactivity series. Let me clear it. Hope you have understood. You can make note of it. Okay, note of these metals with a mnemonic so that you can recall it. Let me clear the drawings. So this is about metal reactivity series and it's easy way to remember. It's mnemonics. Now we'll go for a question time and we'll end up our today's session with a question. State what happens when some zinc pieces are placed in blue copper sulfate solution. For this, you should remember our reactivity series. Zinc are placed in copper sulfate. That means if zinc is more reactive, zinc sulfate will be formed and will be thrown out, right? But you should know whether zinc is more reactive or copper is more reactive just from that reactivity series. Some copper pieces are placed in green ferrous sulfate solution. An iron nail is dipped in solution of copper sulfate for some time. Please try to answer these questions using your knowledge of or memory of metal reactivity series or metal activity series. That's all for this part, children. I'll come back with another part for further discussion of the chapter. Bye until then.